SANDHAN. All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Good afternoon, friend. In TYBSc Mathematics, Mat 303, Semester 5, Unit number 4, Fourier Series. Today we are giving to explanation of Fourier Series and myself, Nutan Patel. So, Fourier series are used in the analysis of periodic function. Any periodic function we can convert into sine and cos functions in finite series. This Fourier series is also used in solving of partial differential equation and heat wave and Laplace equation also. So let it a definition of Fourier series for the periodic function. So when a periodic function f of x in given interval c less or equal to x less or equal to c plus 2l, its Fourier series given as f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos n pi x by l plus bn sin n pi x by l, where a0, an and bn are coefficient. So where value of a0 equal to 1 by l integration from c to c plus 2l f of x dx, an equal to 1 by l integration of c to c plus 2l f of x cos n pi x by l into dx, bn equal to 1 by l integration from c to c plus 2l f of x sin n pi x by l dx. Here a0, an, bn are coefficient. So for finding Fourier series, we require these three coefficient a0, an and bn, and it can be evaluated by integrating. Here interval is c less or equal to x less or equal to c plus 2l. So this periodic function with period is 2l period. Now this interval can be given in any way, like 0 to 2 pi, minus pi to pi, minus 1 to 1, minus 2 to 2, 0 to 2, 0 to 4. Any number of interval is given, we can find its Fourier series. So before going to start Fourier series, let's some integration formula recall. So first here we already know that is integration of cos ax dx, which is same as sin ax upon a, while integration of sin ax dx, which is minus cos ax upon a. Now when we have a product of two function u into v, and to find its integration, that is integration of uv dx, we can find by integration by parts. But sometimes u function is very large, so it's going to large number of integration. So it's a general formula, that is u v1 minus u dash v2 plus u double dash v3 and so on. It is alternative terms where u dash is first a derivative of u double dash is again derivative of u dash. Similarly u triple dash is also can be found, and v1 is integration of v dx, v2 is integration of v1 dx, and v3 is integration of v2 dx and so on. Here u is found by our well-known formula, that is Euler formula, such that derivative of u is vanish. After some times of derivative of u became 0, so we choose some u by ILATS rule. So let's see by tell it off how this rule is working for general formula integration of uv dx. So tell it off. So whenever our integration of x square cos nx dx, here product of two function is given to us. So to integrate this one by simple method, it is very complicated. So by general rule, we choose u as x square and v as cos nx, and by our formula, that is u as it is, so x square as it is, v1, that is integration of cos nx. Integration of cos nx is sin nx by n, minus u dash, that is derivative of x square 2x, and now integration of v1, that is v2 form, so minus cos nx by n, but here already one n, so here became it is n square. Now plus again one more, because here it is again x is there, so again derivative of u dash, that is u double dash, so it is 2, derivative of 2x is 2, into integration of this v2 term, so minus as it is integration of cos, it is sin nx by n, but already n square is there, so we can write here n cube. And now constant term here, so it's again derivative is 0, so here the final integration of x square into cos nx. So this is the use of to find an and bn in our Fourier coefficient. This is a rule to use integration of two function. Now in a slide, now next one, some basic result of sine function and cos function, that is cos 0, its value 0, cos pi, cos 0 is 1, while sin pi is 0, cos pi is minus 1, sin 2 pi is 0, cos 2 pi is 1. Similarly for general rule, sin n pi, that is 0, and cos n pi, that is minus 1 raised to n. And sin 2n pi is 0 and cos 2n pi, its value is 1. That means sin any number of pi, any integer into pi, its value goes to 0. It may be even or odd or any number of pi. While for cos function, if we have even number of pi, then its value is 1. While cos n pi, for any value of n, it gives us minus 1 raised to n. Now let first example of Fourier series. So when given a Fourier series f of x equal to x in the interval 0 less or equal to x less or equal to 2 pi, our standard formula is c to c plus 2l. So first we have to compare the lower limit and upper limit for the given function and find the value of L. So here if we compare the lower limit c equal to 0 and compare the upper limit c plus 2l equal to 2 pi, put the value of c equal to 0 in the second term, so we get 2l equal to 2 pi, and hence our value of L is pi. Here 2l equal to 2 pi, that means given Fourier series function is 2 pi periodic function. Now first we find its Fourier coefficient A0. Its formula is 1 by L integration from c to c plus 2l f of x dx. So put the value of L, f of x and c to c plus 2l. L is equal to pi, limit is 0 to 2 pi, and function is given us here x into dx. So let integrate function of with respect to x and limit 0 to 2 pi. So integration of x with respect to x is x square by 2, and its limit, first we put 2 pi, so 2 pi whole square by 2 minus lower limit 0. So 2 pi whole square, that is 4 pi square by 2, and let's simplify this, its value is 2 pi. So value of A0 first coefficient, that is 2 pi. Now another coefficient an, that is 1 by L integration from c to c plus 2L f of x cos n pi x by L into dx. Put the all value of L, f of x, c to c plus 2L. So L is pi, 0 to 2 pi our integration limit, x function into cos n pi x by L. But here L equal to pi. So put L equal to pi and pi cancel from the numerator and denominator in a cos function. So we get x into cos nx dx. Now here it is a product of two function, x into cos nx, and we want to its integration. So let's use its product rule for integration, u v rule. That is u as it is, so x as it is, v1, so integration of cos, that is sin nx by n, minus u dash, derivative of x, that is 1, into v2, that is minus cos nx by n square. Integration of sin nx is minus cos nx by n square. Now 1 is constant here, so it's again derivative is vanish. So now put upper limit and lower limit. So here upper limit is 2 pi. So put x equal to 2 pi in the given integration formulas. So first term x equal to 2 pi into sine 2n pi. But we know that sine 2n pi, its value is 0. Next, minus minus plus into cos 2n pi. Value of cos 2n pi, that is 1, so 1 upon n square. Even number of pi in a cos function, its value is 1. Now minus lower limit of our integration, x equal to 0. Put x equal to 0, so first term is 0. Again minus cos 0, its value is 1. So cos 0 is 1 upon, and here n square is given, so 1 upon n square minus 1 upon n square. Both are opposite number, they get cancelled and answer is 0. So value of an is 0. Now same way we also find value of bn, Fourier coefficient. So 1 upon L integration from c to c plus 2L f of x sin n pi x by L dx. Now again put value of L, f of x, c to c plus 2L in the given formula of bn. So we get the formula of this bn is 1 by pi integration from 0 to 2 pi x sin nx into dx. To integrate this product of rule, use integration by parts uv rule, that is 1 by pi x as it is, integration of sine minus cos nx upon x, next minus derivative of x, that is 1, and integration of minus cos nx by n, that is minus sin nx by n square, 0 to 2 pi. Here the denominator of cos nx is n. So integration, that is value of 1 by pi, put x equal to 2 pi in the first term. So 2 pi into minus cos 2n pi upon n is there. Minus is there. Now sin 2n pi, its value is 0. Now put the value of lower limit x equal to 0. So x equal to 0 into cos 0 upon n. But value goes to 0. So final answer is minus 2 pi upon n and coefficient 1 by pi. So pi cancel. So we get minus 2 by n. So hence we find a0, an and bn for the Fourier series of given function f of x equal to x. So its standard formula is a0 by 2 plus sigma n is from 1 to infinitive an cos n pi x by L plus bn sin n pi x by L. So let's put all the value of a0, an and bn for this given function. Value of a0 is 2 pi. So 2 pi upon 2 plus sigma. Value of an is 0. So 0 into cos function, that is 0. And value of bn is minus 2 by n into sin n pi x upon value of L, that is pi. and simplify this, it is pi minus 2 outside, that is sigma n is from 1 to infinity 1 by n sine nx. This is our Fourier series of function x. So here we can see that our function x can be written as series of sine nx as pi minus 2 into sine x upon 1 plus sine 2x upon 2 plus sine 3x upon 3 and so on. That means using Fourier series we can write our function into combination of trigonometric function sin x and cos x. Here sine and cos function both are periodic function, so we can analyze our function and solve again periodic functions. So let's second example for different limit f of x equal to x square. Here it is 0 less or equal to x less or equal to 2. Here limit is constant 0 to 2. So again let's find c and c plus 2l by comparing lower limit and upper limit. So let's compare lower limit c equal to 0 and c plus 2l equal to 2. Put c equal to 0, that is 0 0 get cancel. So we get 2l equal to 2. So here our function is 2l periodic function, that is 2 periodic function, its period is 2. Now 2l equal to 2, so we can say that value of l is 1. Now let's find constant a0, an and bn. So here formula of a0 is 1 by l c2 c plus 2l f of x dx. Put all this value. So l equal to 1, so 1 by 1 integration from 0 to 2 x square dx. Let upper limit and lower limit, so it's integration for x square, x cube by 3, upper limit is 2, so 2 raised to 3, 8 by 3 minus